Lesson 5.2 is on estimating probabilities by collecting data. Now, remember, we were talking about, basically probability is like, what are the chances of something happening? Okay, and so now we want to gather some data and be able to make predictions from it. So we're going to pretend we're playing this carnival game. And because we're not together necessarily playing it, I went ahead and did all the spinning. So again, we're going to pretend that this is a school carnival. There's a large spinner, 4 sections, and they spin it twice. Okay, so again, there's like this spinner coming off from the middle. You spin it, and wherever it stops, you get to do it twice. If the sum is greater than or equal to 5, you win a prize. Okay, so I went ahead and kind of did these, right? First spin was 1, second spin was 4. The second turn, the second student, whoever, or maybe they played 2 times, right? Their first spin was 1, their second spin was 1. Third time, it was first spin was 4, second spin was 1. Kind of get the idea, right? But then we're going to add their sum up, okay? Because in this game, if the sum is greater than or equal to 5, so I don't know, we'll say our sum S is greater than or equal to 5, they win. So first one, 1 plus 4 is 5. They would win on that one, right? 1 plus 1, 2. Not a win. 4 plus 1, 5. Winner. 2 plus 3, 5. Winner. 1 plus 2 is 3. 4 plus 3 is, oops, put in the right spot. 1 plus 2 is 3. 4 plus 3 is 7. 3, 7. 3, time to scroll. 2, 6. 2, 3, 6. And 6. Okay, so out of the 15 turns, how many times was sum greater than or equal to 5? Well, that was what we won here, right? 1, 2, 3, 4, 5, 6, 7, 8. That would be 8 times. Okay. Now, I want to write this kind of as a probability, right? So 8 out of the 15. Okay, and that's going to come into play in a little bit. But what we're going to get to here is this is the number of times that were greater than or equal to 5 out of our total number of turns. Okay. Now, what sum occurred the most often? So there are different ways you can kind of represent this. Maybe what we could do is just say, well, what were the sums that we have? What were the possible sums that we could get? Remember, we can get 1, 2, 3, or 4, but we can do it on 2 spins. So the smallest we can get is 2. And that occurred 1, 2, 3 times. Okay, and then we could get a 3. How many times did 3 happen? 1, 2, 3, 4 times. And 4, surprisingly, 4 never happened. And 5, 1, 2, 3 times. And 6, right at the end here, 3 times. And 7, 1, 2 times. And 8. And 8 occurred 0 times. Now I know I'm done at this point because, again, I'm thinking of our possible answers. The greatest one I can get in each spin is 4. 4 plus 4 is 8. Okay, I didn't get 8. Doesn't mean I couldn't have, but on these spins I didn't. So which one occurred the most often, kind of like our mode? Well, that would be 3 here, right? Occurred 4 times. So 3, 4 times. Now, if you play this game some other time, that number might change. Which one occurred the least often? Well, both 4 and 8. Now, if they were to play a lot, what fraction of the games would they win? Well, when we look at this, the key word here is kind of what fraction of the games would they win. okay? And that's going to come back to number 1 here. If you look, okay, at all of these possible outcomes, right? The ways to win are getting a 5, a 6, a 7, or an 8. And for us, that occurred 8 times. Now, this one turn right here, that's one game. We just happened to pretend to play it 15 times, okay? And in those 15 times, we had 8. So what fraction of the games, like in this case, would they be? It would be 8 out of 15, okay? And I'm going to say approximately, right? Because it can change a little bit. But based on what we've done, based on the data we've collected, and I'm just going to say because 8 turns had 5 or greater. Okay, so instead of just playing it once, we did it 15 times. And in our example, 8 out of the 15. Okay, I kind of got ahead of it by putting 8 out of 15 here. It was really just 8 times. Name a sum that would be impossible to get. Well, spinning that twice, what can I not get? Well, I can't get a 0, can I? Can I get 1? No. I said the highest I could get is 8, so could I get a 9? No. 10? No. So I'm going to say 9 or greater. All right. So these refer back to that word impossible, like we talked about in our last lesson. Because number 6 says, well, which one of these is, certain to occur? Well, it's hard to say when you think of it in terms of what answer can you pick that's certain. So think of it more in terms of range. We can't be certain that a 2 is going to be spun after 2 spins, or a sum of 2. We can't be certain there's going to be a sum of 5, okay? But we can be certain that the sums are going to fall from 2, 3, 4, 5, 6, or 7, or 8, okay? So we can be certain that the sum will be between and including, not just between, including 2 and 8, right? We can't be certain which one's going to be picked, but we can be sure that it's going to be a number 2, 3, 4, 5, 6, 7, or 8, because it's impossible to get any other number. So in terms of probability, as we move on here, we're going to start collecting data and figuring it out what the chances are that something we want to have happen is going to happen.